Let's slow it down and take a look at two examples where we're solving equations. So when we solve equations, we are working backwards from order of operations. Our first equation is 2x plus 3 equals 9. So what does that mean? That means we did 2 times x, added 3, and our answer was 9. So we can work backwards from order of operations to see, well, what was that number that we multiplied by 2 and then added 3 to get 9? In order of operations, we multiply the 2 and the x first and then add 3. So to work backwards, we start by undoing this plus 3. We subtract 3 from our answer. 9 minus 3 is 6. And I've undone that addition. I had plus 3, and I undid it by subtracting 3 from my answer. This is sufficient to show work. In the textbook, we'll write that minus 3 on both sides of our equal sign. And what it is, it's just a really great visual way to check, did we do the right step? So the last thing I did was added 3. Yeah, I should subtract 3. When we cancel this out, what we're really doing is saying we undid that step. So we have 2x left on the left and 6 on the right. So 2x equals 6. That means 2 times x equals 6. If I want to undo, well, I got 6 by multiplying 2 times something. I could divide by 2. 6 divided by 2 is 3. Now I'm going to check. I'm dividing by 2 here, and I'm multiplying by 2. So I undid that multiplication. So x has to equal 3. And again, in the textbook, you'll see the division represented with this fraction bar, and you'll see it written underneath on both sides of the equation. And what this is again, a good visual way to check, did you do the right step? So we had 2 times x. The opposite would be to divide by 2. So x has to equal 3. So what does that mean? That means that if we go back and substitute 3 for x, we should get that same answer, 9. So 2 times 3 plus 3 should equal 9. 2 times 3 is 6. 6 plus 3 is 9. And I can say, yeah, I get an answer of 9. That's my solution. If I substitute and I don't get the same answer, it's usually I made a mistake and I can go back and double check my work. That's why it's nice to write at least the left side of the work, that minus as you undo the addition, that division. You have a good visual way to go back and check your work. Let's take a look at our second example. 5x minus 8 equals 22. This means we multiplied 5 times x and then subtracted 8 to get 22. We're going to undo that order of operations and we're going to work backwards. So if the last step I did was subtract 8 to get 22, I'm going to do the opposite and add 8. You can write it just on the left, or you can write it underneath the minus 8 to double check. These are opposites. I subtracted 8, and now I'm undoing it by adding 8. So yes, I undid this step. 22 plus 8 is 30. That's what I'm left with on the right. And on the left, I have just 5x. And again, that means 5 times x equals 30. So if I want to work backwards and I imagine these are big numbers. We don't know our multiplication tables. If I multiply this to get 30, I can divide 30 by 5. I just want to check, am I doing the right thing? What we do to one side, we do to the other. So I was doing 5 times x. To undo multiplying by 5, I divide by 5. Yes, I undid that step. 30 divided by 5 is 6, so my answer should be x equals 6. Again, what does that mean? That means that if we substitute 6 for x, we should get the same answer of 22. So if we do 5 times 6 minus 8, if this is the correct answer, we'll get 22. And I'll let you check that.